Hey everyone, welcome back to your math class and to lesson 12, in which we will be beginning our discussion on exponents. Now, this isn't a complete deviation away from our algebra unit. In previous years, I've done exponents as kind of like a separate unit before we've gotten into algebra, but I wanted us to dive into algebra so you could see kind of how to work with variables and things like that. Just, get used to seeing letters in your equations and get used to solving problems involving those letters, just so you can kind of get a little bit accustomed to the idea. Now we're going to step away from that just for a lesson or two to introduce the concept of the exponent. And then after that, we will go back to algebra, where we will incorporate what we've learned in this exponent section into the algebra. So we can start doing some more complicated algebra problems once we've spent a little bit of time working with exponents. So let's dive right in. So the plan is we're going to begin with a little bit of housekeeping items, just a couple of things that we need to go over. And after that, we'll see if there's time at the end of today's lesson. If this lesson isn't too long, then you guys can go back to lesson 10's word problems, which we've been meaning to get around to for a couple of classes now. After that, we'll finally get into exponents, what they are, why we use them, how they work. And then I've written simple BEDMAS problems involving exponents. That was my original plan for this lesson, but I've actually decided to change it a little bit to keep the emphasis on just working with the exponents. And then probably next lesson, we'll incorporate BEDMAS into that. So this lesson, it's not really going to be any BEDMAS. It's just going to be understanding what exponents are, when we use them, how they work, and after that, the whole point of it is that hopefully the lesson is short enough that you guys can still circle back to lesson 10 for homework. On the off chance that it isn't short enough, then lesson 10's word problems will be homework for Thursday, but more on that in a couple minutes. Looking ahead, I know it looks a little bit weird that, we were working with algebra, we were getting used to seeing x's in our mathematical expressions, and sure, it still looks a little bit weird, but we've been figuring out how to solve those problems. And now we're taking a step away from variables. We're not seeing any letters in the math today, except for maybe once somewhere in the middle. And it looks a little bit weird from the perspective of we were doing algebra, now we're not doing algebra. What's going on? So the idea is, you'll remember hopefully from last lesson when I was talking about algebra and when we were solving some problems, that in order to isolate your variable, you have to do the BEDMAS steps in reverse. And so, I'd give you this expression where you've got the x is stuck inside brackets with, it's stuck to another number through multiplication, and then there's something else being added to it, and you have to do all this stuff kind of following the BEDMAS steps going backwards, right? Starting with addition and subtraction and then working your way towards the beginning of the acronym to figure out what that value of the variable actually is in this particular expression. So the thing with BEDMAS is the E in BEDMAS, that second letter, stands for exponents. But because I haven't covered it with you guys and I'm not sure what kind of exposure you've had to exponents in the past, I didn't want to throw exponents into our algebra unit until I could spend a lesson or two going over the concept with you first. So that's what this lesson is for, is we're going to talk about exponents here and a little bit in the next lesson as well. And then we'll circle back to algebra and we can do more complicated algebra problems once we've got exponents under our belts. So before we jump into the exponents, let's get into the housekeeping items. So, per my understanding, there's been a little bit of rearrangement of, the situation at the school. So it seems that the two classes that have been learning with these videos are now going to be following my lessons a little bit more independently. So before this, you guys had a teacher in the classroom, presumably who could pause the videos and stuff for you, but also who could clarify concepts for you. So now it seems that you guys don't really have that as much. Now, in terms of pausing the videos and stuff, I would like to ask you guys to pick somebody maybe who is the most responsible or who sits near the front of the room or whatever, whoever sits closest to the monitor, to control the playing and pausing when you guys have practice questions. So let me finish explaining before you guys go ahead and pause. But what I'd like you to do is I'd like you to pick somebody who can pause and play the videos when you guys have practice problems to work through. But also, just in general, I'd like you to pick a class representative. So that means somebody who can approach me or approach your other teachers if the whole class is struggling with something. If you're struggling with following the videos without having a teacher in the classroom. If there's a concept that everybody's struggling with and you need to make me aware of that. If there's, noise issues where you guys are. If there's, any kind of problem that affects the whole class. So I'd like you guys to take a few minutes after I finish explaining to pause the video, talk amongst yourselves, pick somebody, preferably somebody who you guys all agree is the most responsible or one of the most responsible students in the class, to be your class rep, so that if there's any problems with the videos, if there's any problems that affect the class as a whole, they can be that one person that you go to, and they'll be sort of the mode of communication between myself, your other teachers, and the rest of the class. Now, obviously, you guys all have pretty easy direct access to the rest of your teachers, but not so much to me. And so I'm not sure, how many of you have found my Instagram or how many of you have gone looking for these YouTube videos on your own. So if I can have that, this one person in this class and this one person in that class are my go-to people to communicate something directly and quickly to the rest of the class, I think it would be helpful to do that. So take a couple of minutes, talk amongst yourselves and pick somebody to be your class rep, somebody who obviously is willing to take on that little bit of responsibility. Just in general, any issues that affect the class, and also the kinds of progress that you're noticing in the class. So if everybody's struggling with a concept and you're taking a little bit more time to work through the videos, I should be aware of that so I'm not making super long or super frequent videos if it means that you guys are going to be if it means that you guys are going to be falling behind or getting overwhelmed, right? So take a couple of minutes, and if you're not sure in today's class, you guys can take some time to think about it, but try and get back to me or to one of your teachers in a couple of days to get that sorted, just so that we can keep the communication as easy as possible. So yeah, go ahead and pause now. All right, so assuming you guys have now taken the time to have that chat amongst yourselves about who your class rep is going to be, we're going to move on to one more brief housekeeping item here, which is bilingual lessons. So I'm not going to be teaching the lessons in like half English, half Spanish, but I was recently informed that the students in one of the classes, I know which class, but because these videos are out on the internet, I prefer not to use names. But I was informed that students in one of the classes is comprised of, one of the classes itself is comprised of mostly Dominicans, which obviously makes sense given where you guys are, and that as a result it might be beneficial to have some of like the word problems and stuff written in English and in Spanish, just to make sure that the question being asked is understood. So I'm thinking I've pretty much got confirmation for this now, but since we're not doing any word problems for real today, you're not going to see it in this video. But going forward, when we do word problems, obviously besides lesson 10, because that's already been recorded and uploaded and all that, going forward, lesson 13 onwards, whenever we have word problems, you will find that the question itself will be given in English and in Spanish to make sure that everybody understands what's going on. And then I'll see about quizzes and tests. I might also make the instructions for every question on a quiz or test fully bilingual as well, just to make sure that everybody understands what's going on, because obviously this is a math class, not an English class, not a language class, right? So I want to understand where you guys are with the math, right? If I give you a test, I want to make sure that the grade that I'm getting out of marking your tests comes from your math ability and not your English ability or your Spanish ability, right? So that's why I wanted to put that out there as well. And I just spoke briefly about this at the beginning, but the word problems from lesson 10, unfortunately, I don't have the timestamp. I should have put that in here. But towards the end of lesson 10, there were 2 word problems, I believe. And for a couple of lessons, we've been trying to get there. You guys spent 2 classes ago, you would have been doing lesson 10, but didn't quite make it to the word problems. And then last class, you went through lesson 11, but again, didn't quite get to those word problems back from lesson 10. So if today's video is short enough, you guys can circle back to lesson 10 and maybe tackle the first word problem or something. If today's lesson isn't short enough, then that's going to be homework for Thursday. So basically, if you end up having to do it at home, I would like you to sit down. It's not going to take you that long. It's going to take you maybe 15 minutes, 15, 20 minutes. Sit down with the YouTube video and pause it when you can read the word problem, but you can't see the answer. So there'll be a pause thing on the screen. Pause it there. Take a few minutes to try and figure out what you're supposed to do, figure out how to work out the problem. Just sit down with your notebook for 5-7 minutes, try and figure out what you're supposed to do, see if you can get an answer, and then see my solution and see if the answers match, see if the process is the same or if the process is different, see if my process made sense to you, and double check that you kind of took all the right steps. And yeah, I just want to make sure that that you guys are able to see those word problems and get some sort of an understanding for you know, whether those problems make sense to you, because I recognize that I made those questions a little bit challenging. So I'm eager to see how you guys find those questions as well. But yeah, so that's homework for Thursday if you guys don't get a chance to circle back to it today. All right, now I got my light on, so you guys can hopefully see me a little bit better. When I started recording, the sun hadn't set yet, but now it's going down fast. So, all right, now that we can finally jump into the math. So, what are exponents? So, in order to answer that question, what we're actually going to do is we're going to go back to basics and we're going to ask, what is multiplication? And this is going to seem a little bit random for a minute, but bear with me. So, what is multiplication? You'll see what I've written here is that multiplication is repeated addition. So what does that mean? So that means that if I were to give you an expression like this, where I say 3 plus 3 plus 3 plus 3 plus 3 plus 3, so that I've got 10 threes, right? So that I've got 10 threes all being added together. What multiplication allows you to do is it saves you from having to write down 3 plus 3 plus 3 plus 3 plus 3, 10 threes, right? With plus signs in between. And you can just write 3 times 10, right? So that you've got a 3 and it's being added to itself 10 times. That's what multiplication is telling you, right? If you had a whole bunch of threes, if you had 37 of them and you had to add them all up, you could write 3 plus 3 plus 3 plus 3 plus 3 37 times. It would take you a really long time and then it would be really messy to add up. So multiplication allows you to write it in this more compact form, 3 times 37, right? That's what that is, that you're adding 3 to itself 37 times. That's 3 times 37. That's just what it is. And speaking generally, this is just a little sprinkling of algebra and where it can kind of be useful, is we don't have to use specific examples of 10 times and 37 times. We can say some number of times, n number of times, you're adding threes to itself, then ultimately that's going to just be 3 times n, whatever that n is. If n is 10, it's going to be 3 times 10. If n is 37, that means you're adding this to itself 37 times, so that's 3 times 37. And if it's some other like way bigger number, then it's going to be 3 times that way bigger number, right? So it's there's just your sprinkling of algebra. But yeah, so the unique thing, or not unique, but the useful thing with multiplication is that it's not just a convenient way to write down this expression of 3 plus 3 plus 3 plus 3 37 times. Sure, it takes a long time to write that down. It's a little bit complicated to go through all those separate steps of addition. Absolutely. But when you write it down as 3 times 37 and you call it multiplication, it's like this new tool that you've built out of your old tool, which was addition. But with this new tool, you can do math in a different way, right? For instance, long multiplication. You don't have to sit there and write 3 plus 3 plus 3 37 times. You can write 37 times 3, and you can actually do the long multiplication to figure out what that answer is. So you essentially what multiplication is doing is this: 3 plus 3 plus 3 37 times. But what you're doing with 3 times 37, you're not actually really doing any addition. You might do a little addition in your longer problems, right? You do your long multiplication and then your last step is a little bit of addition. Sure, but you're not really doing this 3 plus 3 business over and over again when you're solving a multiplication problem, right? Here you would do 3 times 7, you'd do 3 times 3, a little bit of addition with the number that you carry over, and then that's it. There's your answer, right? So it allows you to do math in a different way. It follows different rules. It follows different processes to get the answer, but it'll get you the same answer as adding 3 to itself 37 times. So that's an important thing to note about multiplication, is it's not just an easy way to write it down, it's actually an easier way to do the math. So like I said, that might seem a little bit random. What does that have to do with exponents? So the reason I wanted to talk about addition and its relationship to multiplication is because that relationship between addition and multiplication is the same as the relationship between multiplication and exponents, or the process is called exponentiation. So what does that mean? So we went from addition to multiplication by saying that multiplication is addition repeated over and over and over and over and over again, right? So you've got 3 plus 3 plus 3 plus 3 as an addition problem. You can rewrite that as a multiplication problem, where it is not only easier to write it down, but it's easier to do the math with it, right? Now, if multiplication is repeated addition, and then exponents, exponentiation, is that same relationship, that means that exponentiation is repeated multiplication. That's what I've written on the screen. So instead of having 3 plus 3 plus 3 plus 3 being 3 times something, now it's 3 times 3 times 3 times 3 times 3. And now you're multiplying by the same number over and over and over again, right? So now it's, instead of in every single thing here, it's just like on the previous slide, except instead of plus signs in between, now it's multiplication signs. So 3 times 3 times 3 times 3, 10 times. So like having 10 threes with multiplication signs in between them. We write that like this. And this little 10 up here is your exponent. So that little guy right there, this 10 right here, is what we call an exponent. And what that's telling you is that you're taking 3 and you're multiplying it by itself 10 times. So you're going to have 10 threes, right? Maybe I'll write them all out just so you can see, because this is your first time. So that's 7, I think, 8, 9, and 10. And there's multiplication signs in between all of those, right? So that's 3 times 3 times 3 times 3, 10 times. And so that is what an exponent is telling you. So this 3 with the little 10 up top, that's telling you that this is actually the question that you're trying to solve. So have we got 10 threes here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so that's telling you that it's 10 threes all being multiplied together. That's what that little 10 up there is telling you. And you'll hear people say this as 3 to the power of 10. That's fine. You could hear 3 to the exponent 10. That's also fine. But basically it's going to be one of those two. It's either 3 to the power of 10 or 3 to the exponent 10. Now, I've said it both ways. One thing I will tell you guys that I actually meant to put on the slide but then forgot is that this 3, the big number that's not like the big number that you end up multiplying over and over again, right? Here we're multiplying a bunch of 3's together. That's this big number right here. That's called the base. All right, that's called the base. The little guy, the one that tells you how many times you're multiplying it together, that's the exponent. I'm not going to write out the whole word or the whole word, but I will write exp. That's going to be your exponent. And the whole thing all together, this entire thing, is called a power. And so that's some useful terminology for when you're just dealing with exponents, when you're working with exponents. But yeah, so there you go. So 3 to the exponent 10, or 3 to the power of 10, that's this thing. That's 3 times 3 times 3 times 3, 10 times. So you've got the number 3 showing up 10 times and multiplication signs in between. If it were a bigger number or a different number in that little exponent, if it was 37, that means you've got 37 3's all being multiplied together. Once again, that's going to take you forever to do in 37 little mini steps of math, right? So with exponents will play by some different rules, which we'll explore a little bit later on, not in today's lesson, but a little ways down the road. And of course, once again, just for consistency with the previous slide, if we had just some number, n, 3 to the n, that means you've got 3 multiplied by itself n times. We're not sure how many, or we don't care how many, right? So this is an example of where we don't care how many. We're saying if you multiply 3 by itself some number of times, doesn't matter, then you'll write it as an exponent, or as a power, by saying 3 to the exponent of whatever that number is. Cool, so I hope that makes sense. Of course, let me know if it doesn't. And now let's dive into some more actual math with it. So, yeah, this is basically stuff I've already said. So we use exponents when we're multiplying by the same thing over and over again, similar to how we use multiplication to represent adding the same thing over and over again, right? Now, just a quick note is that exponents like to show up in situations where you've got some sort of process that involves multiplication or division, and then that process can repeat. So you keep multiplying or dividing by the exact same number every single time. Now, the idea is, we'll get into the practical applications of that a little bit later on, but just as a simple example, if you've got a sheet of paper and you fold it once, suddenly the thickness of that folded sheet is twice as much as the original, right? If you have a sheet of paper, it's got a thickness of like 1 millimeter, but then if you fold it, then suddenly it looks like this, right? And now it's twice as thick because you've got this thickness being added to this thickness, right? And then if you were to fold it again, then it would look something like this, right? And now it's 4 times as thick. So every single time that you fold a sheet of paper, you're doubling how thick that little folded sheet looks, right? So first, if this was 1 millimeter over here, then this will be 2 millimeters, this will be 4, and so on. It'll keep doubling, it'll keep multiplying by 2 every time that you fold it. So that's an example of something where using exponents to do some math with, like talking about the thickness or whatever, would come in handy, because every single time that you do that process of folding, the thickness gets multiplied by 2, and then you can always repeat that folding process. So you can repeat that multiplication by 2. So that's just a little sort of warm up for going forward with exponents of where they might be useful. So we're not going to worry too much about that right now, about where exactly they're going to come into play, but we'll see that a little bit down the road from today. So here are some examples. So I'm going to go through these with you one at a time. And what we're going to do is we'll start with this first one. So we've got 3 to the power of 4, or 3 to the exponent 4. So 3 is our base. Well, let me get my laser again. 3 is our base. So that's the number that's going to be multiplied by itself a whole bunch of times. So it's going to be 3 times 3 times 3. How many 3's? That many 3's. 4, because 4 is the exponent. So it's telling you how many times that this big number, the 3, is going to show up. So if I get rid of that, oh, I can't do it with the laser pointer on, like that. So we can see here that we've got 3 being multiplied by itself because that was the base, that was the big number, and it's being multiplied by itself how many times? 4 times. The number 3 shows up 4 times here because we've got a 4 in the exponent. And then you can just hash out that math. 3 times 3 is 9, times 3 is 27, times 3 is 81. And that's the answer to the first one. So now this second one, now we've got 5 to the exponent 3. So what's going on here? Well, the base, the big number, that 5, is what we are going to be multiplying by itself a whole bunch of times. It's going to be 5 times 5 times 5. How many times? Whatever the exponent tells you. So the big number, the base, is telling you what number you're going to be multiplying by itself, and the exponent, the little number, tells you how many times you're going to be multiplying it. So putting those two pieces of information together, you get 5 times 5 times 5. 5 is the number that's being multiplied together because it's the base, and it shows up 3 times because of the 3 in the exponent. And then you just hash out the math. 5 times 5 is 25, times 5 is 125. Now for example C here, we've got 7 to the power of 2, or 7 to the exponent 2, or 7 squared. We'll talk about squares and cubes a little ways down the road, but this is 7 squared, and that means that you're going to be taking that base, 7, and you're going to be multiplying it by itself. How many times? How many 7s are you going to have? 2, because we've got a 2 in the exponent. So we get 7 squared is the same as 7 times 7, which is 49. That's it. D, we've got 2 to the exponent 5, or 2 to the power 5. So that means the 2 is what's going to be multiplied by itself. How many times? 5 times, because that's what the exponent tells you. So there should be 5 2's all being multiplied together. So if we click on this, we get 5 2's. 1, 2, 3, 4, 5, and they're all being multiplied together. So there's 5 of them because of the exponent, and there's 2's, like that they're all 2's, because that's what the base is. And then you just hash out that multiplication one step at a time. 2 times 2 times 2 times 2 times 2 gives you 32. And the last one, 10 to the exponent 6, or 10 to the power of 6. That means you're going to be multiplying 10 by itself 6 times. So there's going to be 6 10's, all with multiplication signs in between them. So we get 10 times 10 times 10 times 10 times 10 times 10. So basically we're just adding a whole bunch of zeros, but 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000. So 10 to the exponent 6, or 10 to the power of 6, is 1,000,000. All right, so now let's revisit that folding paper thing I was talking about a couple slides ago. So suppose we've got a sheet of paper that's 1 millimeter thick, right? So basically what we're saying is I draw out the same thing I drew before. So here's your flat sheet of paper that's 1 millimeter thick. If you fold it once, it's going to look like that, and now it's going to be 2 millimeters thick. If you fold it again, it's going to look something like that, and now it's going to be 4 millimeters thick. If you fold it again, it's going to be even thicker. It's going to be twice as thick every single time, right? 1 to 2 to 4 to 8 to 16 and so on. And the question is, how thick will the folded sheet be after 8 folds? So without any folds, it's got a thickness of 1. After one fold, that goes up to 2. After another fold, it goes up to 4. And then it goes up to 8 and 16, because we're doubling every single time, right? We're multiplying by 2 every single time. So if you guys want to take a stab at it, you can, but I'm not asking you to solve this problem on your own. So I'm going to show you the solution now. Yeah, so the thickness after each fold simply doubles. That's what I was just saying a second ago. So that means that you take the thickness that you had and you multiply it by 2, right? That's what doubling is. So we just need to count the number of times that that should actually say that the thickness doubles, right? This right here shouldn't say the fold, it should say the thickness, but you know what I'm trying to say, hopefully. So the thickness after each fold simply doubles, right? We need to count the number of times that that thickness doubles, so how many times that we're folding the page. Now, we already know, we're being asked in the question, that if we fold that one sheet of paper 8 times, how thick is it going to be? So we know that we've got our original thickness, right, of 1 millimeter. And if we fold it once, then that means the thickness is going to be multiplied by 2, right? That's with one fold. If we fold it again, now we multiply by 2 again, because the thickness doubles. If we fold it again, it doubles again. If we fold it again, it doubles. If we fold it again, it doubles. That's the 6th doubling. That's the 7th. That's the 8th. Now, that's a whole lot of stuff to write out to solve this problem. So instead, we recognize that every single time that we fold the sheet of paper, the thickness doubles, right? Every single time that we fold it, there's going to be an extra times 2. But if there's just going to be a whole bunch of a number multiplied by itself, we can write that as an exponent. So all we have to do to write that as an exponent is we count out how many of these 2's we have. First, we have to make sure they're all being multiplied together and there's no addition or any other funny business going on. So 2 times 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 2. That's 8 instances of the number 2. So it's going to be written as 2 to the 8, which is what we have here, right? So that's, oh, that's a horrible 2. So it's 2 to the 8, as if we write that as a power, because it's 2's being multiplied together, and there's 8 of them that are being multiplied together. So that's how we would write it. And then you can hash out that math, which is basically just doing this multiplication. This isn't your greatest example of seeing why using exponents are useful. That's going to come a little bit later on. Right now, I'm just trying to explain the idea of what exponents represent. But doing that calculation and multiplying 2 by itself a bunch of times, you should get that the answer of that folded sheet of paper 8 times should be 256 millimeters thick. So that's 25.6 centimeters thick. So about, like, I don't know, that thick. So if you took a sheet of paper that was 1 millimeter thick and then you folded it just 8 times, it would get up to 25 centimeters, which is, that's pretty cool. And I think there's a Mythbusters thing somewhere about folding a sheet of paper more than 7 times or something. So you guys can try it, see if you can figure it out. All right, and here are some practice problems. Now, looking at the recording time, chances are this is going to be where we end for today. So lesson 10's word problems, those can be homework. But yeah, so you guys can pause the video and try and solve these 5 questions. And then we will get into, I'll show you the answers. So take a few seconds to pause the video and then we'll get into the answers. All right, so now we can get into the answers for these 5 questions. So the first one is 2 to the exponent 7, or 2 to the power of 7. So that's 2's all being multiplied together 7 times. So you're going to write out the number 2 7 times and then multiply those all together. So you get 2 times 2 times 2 times 2 times 2 times 2 times 2, which is equal to 128. And the way I like to sort of think it through when I'm just writing it out like this is I like to say the answer I get at each step. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. The second one is 3 cubed, or 3 to the power 3, or 3 to the exponent 3. So that's 3 being multiplied by itself 3 times, because that's what the exponent tells us. So we get 3 times 3 times 3, which is 27. 3 times 3 is 9, times 3 is 27. Next, we've got 4 to the power 4. So that's going to be 4 times 4 times 4 times 4. It's 4's all being multiplied together, and there's 4 of them because that's what the exponent tells us. And you'll see that that's actually a pretty big number, right? That's 256, which we also saw in the previous question. So one thing you guys are going to notice with exponents when we start to do a little bit more work with them is you'll see that they get really big really fast, right? Just the same way that going from addition to multiplication, the numbers start to get bigger, right? Doing addition you know, when you guys were a lot younger doing addition problems, you'll be dealing with numbers in the 10s and the 20s, and then you start doing multiplication and you've got 9 times 8 is 72. Like that's a huge number compared to like 15, 16, 20, the kinds of numbers that you might have been working with before. Similarly, with multiplication, you get used to dealing with numbers like 9 times 7 is 63, or like, you know, whatever, 9 times 11 is 99, things like that. And then you get into smallish looking numbers, 4 to the power of 4, that just looks like, oh, it looks like 4 times 4. It looks like it might be around 16. No, it's bigger than 200 and by quite some distance, right? So that's something you guys are going to find with exponents, is that the numbers get really big really fast, just like how multiplication does that to addition. So the next one, we've got 9 squared, or 9 to the power of 2, or 9 to the exponent 2. So that's 9s being multiplied together 2 times. So 2 9s being multiplied together. So we get 9 times 9, which is 81. And then the last one, you guys might need to do some long multiplication to figure this one out, because 11 cubed, or 11 to the power 3, or 11 to the exponent 3, that's 11 times 11 times 11. So if you know your perfect squares, if you know your number times itself, your square numbers, then 11 squared, 11 times 11 is 121. But then you're going to have to do 121 times 11, right? So this piece right here, 11 times 11, that's equal to 121. But then you have to do 121 times 11, which you might need to do your long multiplication for to get this answer of 1,331. So that's it for the practice questions. I hope that all made sense. I know I took it a little bit slow, maybe too slow for some of you, maybe not slow enough, just let me know. But because it's a new concept, as far as I'm concerned, working with you guys, like because I haven't seen where you guys stand with exponents thus far, I wanted to make sure I take some time to really ease you into the concept, and then in the next lesson or two, we'll kind of ramp up the pace, and then we'll dive back into algebra with everything that we learn from exponents, from this video and from the next lesson or two. So yeah, that is everything for today. I don't think there's time for you to go back to lesson 10. If there is, by all means, give it a try. But other than that, I will stay tuned for any questions that you guys might have. And if that is, I think that's all. So I will see you guys in the next video on Thursday. Have a good one.